Okay, hi everyone. I should try to be efficient here because this could end up taking a while. I just get curious with data. So, okay, you see I've loaded the data set about county demographics into this object CDI here. And I typed the head command, which defaults to give the first 6 rows. And I would like to do some kind of test where I see some effects of multicollinearity. So I'm thinking we should probably try to keep it pretty simple. And the one that seems, so if I go through county, state, land area, population, percent 18 to 34, percent over 65, percent, no, not total number of doctors, total number of beds, total number of serious crimes, percent high school grad, percent undergrad, percent below poverty level, percent unemployed, per capita income, total income, and a region identifier. So, yeah, it seems like we should stick with all percents and to predict maybe one of the totals, right? That might make sense. Could you also go with all totals to predict the total? All percents to predict a percent. Yeah, so I think we'll do is look at, should probably thought this out more for. So let's do a model. Let's call this mod 1. We'll just try to keep track of these. And let's call this, let's say LM crimes, I guess, as a linear function of. Now let's just take percent. So let's take poverty plus unemployment plus HS grad plus HIPS. Maybe that's enough. Plus university grad, maybe. And just see what we get here. So, oh, I got to tell it where it is, right? So data equals CDI. Okay, mod 1 summary. Mod 1. Let's just see what we get here first. Okay, so if I do this, I have, it's weird, right? I get, okay, several things that are interesting here. So, and look, let's take this video as to an action item for you. If we raise a question here, I want you to think about the question and feel free to email me or even comment on the video and post an answer. If here I have these coefficients here, and I see the negative sign, the minus sign next to the high school grad, which makes sense that people that graduate have better opportunities, graduate school, and maybe less likely to go into crime, and crime does not pay, in case you were wondering. But look here, the university grads is actually positive. That's very strange. Okay, so that's and it's very significant here too. So that's my first question, is why is the university grad coefficient positive here? Something to think about. It might be too much, it might be too complicated to answer, but at least think about it. Okay, so let's see what ANOVA says. So ANOVA and mod 1. Okay, so here's my extra sum of squares. This one is good, and they're reduced now. But look here, even with these other ones in the model, these are significant here for the hipster and the university grads. So university grads looks important somehow, and but you know, I still got to be careful about making too many conclusions too fast based on these two calls here. So so what should we do going forward? Okay, I think the first thing to do to check is that the coefficients will change if I take things out of the model, because I'm going to assume these are correlated. Now, I can check the correlation of these pretty quickly if I use this command. So let me do correlation. I'm going to round it too. So round, let's just round it to 1 decimal place. Correlation of CDI data frame, and I will round it to 1 decimal place. What the? Error in core CDI. What did I do? X must be numeric. Oh, core CDI. What the hell? How is this supposed to work? Core CDI. What the hell? Core CDI. Yeah, it can't deal with some of them that are not numeric. So let's do this. Let's just put in the ones we need. So we will core, and in here I will cbind. Let's just say a few of these. So just to see the ones we care about, right? So we have CDI $, PO poverty, CDI $, unemployment, CDI $. Let's just take university grads, and maybe that's enough. Just let's look at maybe CDI $, high school grad, CDI $, hipsters. Okay. Okay. I make this call now. I can see how these are correlated, and actually, kind of interesting that the first one, poverty and the hipsters, are uncorrelated, at least rounded down, and but the other ones have a reasonable amount of correlation. You know, there is 0.4, 0.4, 0.7, 0.5, 0.6, 0.7. So the other ones are reasonably correlated, and I expect some effects of multicollinearity. So let's just take a few of these now. The ones that maybe seem interesting, like the hipsters, the university grads, and the poverty level, people who are poor. So let's redo this. We'll call it mod 2 now and make this equal to LM. Let's try to reuse the call here, and we'll just take university grads. We'll take the hipsters, I guess. Don't really want to, but we'll take them. Somebody's got to take them, right? And poverty. Okay, and we'll call this mod 2. Okay, so with mod 2 now defined this way, let's look at, by the way, I think I can do a correlation on mod 2. Let's see what happened. No, it didn't work. Okay, so let's see what happens, but we know how these are pairwise correlated anyway from up here. So let's look again, let's look first at the summary command. Okay, and let's look at our coefficients. Okay, and we'll look at mod 1 coefficients. Okay, so for mod 2, so here I had poverty. Look, I didn't do this ahead of time. I just knew they would change because of the multicollinearity. So here, originally with all of them, this had a 1500, and now it's doubled almost when I reduced it, the poverty level as an indicator. The hipster, look, the hipster shrunk a lot when I reduced it. I don't know how to explain this. Totally, we'd have to analyze it much more carefully. It's much more complicated with more than 2. So it's not so simple as saying they're one is positively correlated or negatively correlated. It's the way the whole system's acting. There's a lot of approaches. There's a lot of papers. You can read a lot more textbooks you can read on this too. So if you're interested, you can ask me. Here we have, this one changed as well too, right? So they all changed when I reduced to the simple model. These two went down, the university grads and the hipsters, their coefficients went down, and the poverty went up. Okay, so now the only other thing I want to check is just the ANOVA. So I had ANOVA mod 1 and ANOVA mod 2. Let's get these both on the board, I hope. Yeah, okay. So if we look at these should change too. Here, poverty didn't change. That makes sense, right? It's the first one. So this is the SSR poverty. That didn't change. That's good. That's what we wanted to see. Now let's go to the other two we included, which was hipsters and undergrads. University grads. Shows you where my head's at. The hipsters, well, it didn't change much actually, but it did change, right? It dropped by, well, 10 to the 8th, but compared to this magnitude, that's not much. And the university grads changed on the order of 10 to the 10th. So that one changed. So this was the demo in R. I don't want to make it too long or it'll take forever to upload. The marginal sums of squares change when the predictors are correlated. We can do more interesting examples. If you want to see more, come to the optional help sessions, and this is what we do in there a lot. So I should get out of here before I make this too long, and then I can't use my internet.